Hello everyone, my name is Loveleen and in this video I'll be demonstrating the task 2.1p. So basically talking about the requirements of the task. So we already have inbuilt functions which are used to set the state of the pin or to set the pin as input or output or just to read the pin state. So basically what we are supposed to do in this task, we have to create our own methods to do so. So first is this GPIO deacon.cpp file, and the first thing it is importing from the header file, which is the GPIO deacon.h file. So basically we are allowing the implementation file, and it is basically accessing the class definitions from the header file. So the first few three lines, we are defining the memory address for the direction, for the output, and for the input for the registers of port A. And so basically, as you can see here, I'm defining the output, here is the input, so we are defining it in the memory. So basically these are used to manipulate the GPIO registers. Then is our first method of config.gpio. So what we are doing here is, first we are defining this method and we are implementing the GPIO deacon class, and then we have the port number, which can be like A. Then we have the um, pin number over here, and then we have the mode, which can be input or output. So after that, what we are doing, we are checking in this line if the provided port number is A, and if it is not, then we are returning false. After that, here we are checking if the provided mode is output, and it is, then the corresponding bit of that output of the corresponding bit of that pin number is basically being set to that output mode. And basically this operation right here, it is shifting the bit 1 to the left by the pin number position. So basically we are targeting that specific pin. Similarly, we are checking for the input, and if it's neither of these, we are returning false, which means that it is an invalid mode. And then we are here returning true to indicate that we have the configuration of the pin. Okay, after that we have the write GPIO method. So basically, again, we are here taking in the three parameters, which is the port number, the pin number, and the state. And then in the first line, we are checking if it is the port number A, and if it is not, then it is returning false. After that, we are checking the state of the state. If it is high, then the corresponding bit for that pin number is set in the output register to high state. So basically we are setting that bit to high, or either that we are setting it to low, similarly using this. And then we are returning true to say that we have set the state of the GPIO. After that, we have this read.gpio function. So basically again it is taking two parameters, which is the port number and the pin number. So basically we are here returning a boolean function. Over here we are returning a boolean function to indicate the state of the pin, which can either be high or low. Then this line is checking if the provided port number is A, and if it is not, the function will return false, because this is only handling port A. um, and then we are returning this line is basically reading the state of the pin by checking the corresponding bit for the pin number, and if the bit is already set, it is returning high, which is true, otherwise it will return false. After that, we have the deacon.h file. So basically what we are doing here, first we are including the we are first defining the file, and we're including the arduino.h file, which is our header file for which is the INO file. And then we have defined a class, and so basically we are just mentioning all of our methods and everything. After that, we have this arduino .sketch file. I haven't changed the name yet. So basically first we are including the header file, and then we are creating an instance of it, and then this is our setup function. So basically we are configuring the GPIO pin 821 as an output, and we have used this method. And then we have the loop function, wherein this is set to high and then there's a delay of 1 second introduced, and then again it is set to low, and the delay of 1 second is introduced again. So this will basically make sure that the LED will blink on and off every 1 second. Now I'll be demonstrating this using my hardware. So this is my code and I'll just upload it. As you can see, it says done uploading over here, and the LED is blinking with a gap of 1 second, and that is because of the delay that I've added over here is of 1 second. Talking about the hardware, this is the Arduino Nano, which is connected at D10 and ground. Then we have the LED and a resistor.